So here we have our rules. If you have powers with the same base, you can add those exponents. And the reason it works is, remember, way back in elementary school they said, oh, what does x to the fifth mean? And you're like, x times x times x times x times x, right? Easy problem. And they're like, what does x to the third mean? And you're like, x times x times x. And they're like, what does this mean? It's like, oh, that's x multiplied by itself 1, 2, 3, 4, 5, 6, 7, 8 times. Oh, that's x to the eighth. It makes sense. It works. In the beginning, you wrote it out so many times your hand hurt, and then you're like, I'm not going to write it out anymore, and then you forgot. But you can always remember. So x to the fifth cubed, if I'm cubing something, it means I'm multiplying it by itself 3 times. So that means it's x to the fifth times x to the fifth times x to the fifth. And x to the fifth is x times x times x times x times x, and then times another x to the fifth, so x times x, and then times another one, so do 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 do. How many x's are multiplying together now? Oh, x to the 15th. So powers to powers give you superpowers. Go ahead and multiply those powers when it's like that. Here, if you're dividing powers, go ahead and subtract the exponents. Excuse me. So you can have x times x times x times x on the top, and x times x times x on the bottom. And these x's are making 1s when they cancel, so you're left with 2. It works. What if there are more on the bottom than there are on the top? Well, then they just end up canceling and leaving them on the bottom. So it's 1 over x squared, which is the same as x to the negative 2, which is the same as if you had done 3 minus 5 to give you minus 2. So many ways of thinking about it. But yes, whenever you're confused, you're like, oh, do I add them? Do I multiply them? What's going on? You know, take a second, multiply it out. It works.